Today we're going to look at graphing parabolas in terms of conics. Our objectives are to be able to find the vertex, focus, directrix, and focal width of a parabola, and to be able to graph a parabola from standard form. So what are these parts that I'm talking about? Well, some are going to be familiar to you and others are going to be a little bit new. The vertex is still the same, but we're going to talk about this thing called the focus, which happens to lie in our axis symmetry, and this basic imaginary line called the directrix. Now these have always existed before when we graph parabolas or our quadratics, but we've just never talked about them. But they are how we define what a parabola is. A parabola is this set of points that are equidistant or the same exact distance away from these two items. So any point on this parabola, if I find the distance to this focus point and find the perpendicular distance to our directrix, they will be exactly the same no matter where I am on there, which means that this vertex right here too, if it's the same distance, I know the distance from here to here, my focus is going to be the exact same from here to my directrix, and that's going to be really important for us being able to graph these today. So what is our standard form of a parabola? Well, we have two different types of parabolas now, or four if you want to actually think about it. We have our standard one where they face up or down, but now that we're dealing with conics, we're actually going to talk about the ones that face right or left. And our two equations are extremely similar, but with one little change. When it faces up or down, the x part, my x minus h, is the part that's squared, and when I'm looking right or left, we flip it, and it's the y minus k part that's squared. And how I remember this is we've typically only dealt with parabolas that face up or down, and in those equations, the x was always the part squared, y equals x squared. But now, when we talk about the weird ones, the ones that face right or left, it's going to flip. Now the y is the part being squared, and that's how I always remember it. So if I'm used to x being squared, that's my normal up and down. The y being squared, it's left to right. And we still have these h and k's, which you probably remember hopefully from vertex form. But now we're going to have this new part, this 4 times p. And this p is probably going to be the most important thing when helping us to graph. So how are we going to use this? I know this page looks kind of complicated, but we have my two different forms. No matter which form you're in, the vertex can be found by looking at the h value, comma, the k value. And the h comes first because it's with the x. The k is second because it comes with the y. And if you notice, I don't have negative h, negative k. So remember, like we did in vertex form, it's always going to be the opposite value. So if it says x minus 2, the h is really a 2, so I'd write down 2. If it said x plus 2, that's the same thing as x minus a negative 2, so I would write down a negative 2. So we're always going to do the opposite of what it looks like in my parabola with my h and k. If I look at the 4p part, the number that's in front of my parentheses without the squared term, if I take the absolute value of that number, I'm going to get the width of the parabola at the focus. So it's going to tell me how wide my parabola is. If I go to the focus and go across or up and down, that's going to tell me how wide the parabola is. And that'll help us get a more accurate graph. And p, like I said, is the most important part. P tells us the distance from the vertex to the focus. So if p is positive, we're going to either move up or right, because when we have a positive value, or when our equation is positive, we get our normal up parabola, or in this in the case of left and right, a right parabola. If we have a negative value, it's going to be our downward facing parabola or our left facing parabola. Now, because the vertex is smack dab in the middle of the focus and directrix, if I know the p tells me how to get to the focus, if I go the opposite direction from the vertex, say again p units, I'm going to get the location of the directrix. And then we're going to go through 4 examples to kind of help us go through this. In my first example, I can see that it's already in standard form. I have my squared term equaled some value in front of my parentheses. Now because my x is squared, I know this is an up or down parabola. So how do I know which one it is? Well, that's where this number comes into play. If it's positive, it faces up. If it's negative, it faces down. So since this is positive, my parabola is going to look like this. It's going to face up. So now I need to know, well, where's my vertex? And my vertex is actually on the parabola. So let's see what that's going to look like. My vertex is in x comma y. I find the x by looking at my parentheses with the x in it. It says x minus 3, so I'm going to do the opposite value and write a positive 3. It says y plus 5, so I'm going to do the opposite and make it negative 5. So I like to kind of graph as I go, so I'm going to go over 3 and down 1, 2, 3, 4, 5 and put my vertex. Now again, you can kind of visualize what this looks like. This is my vertex, which is on the parabola, and it's going to go something like this. And I know my focus then is always going to be inside the parabola, and my directrix is sometimes somewhere outside the parabola. Okay, so how do I find this focus? Well, the important thing for the focus is to look at this value right in front. That value is equivalent to 4p in my equation. So that's 4p, and I know in my equation it says it's equal to 4. So if I divide both sides by 4, I know p equals 1. Now you don't write a 1 here because the focus is a point, but this is going to tell me where to move for it. I'm going to move up 1. So if I go from here and I move up 1, I get the focus. And I always like to do an X, so I know which one is the vertex, which one's the focus. And remember, the focus isn't actually on my parabola, and you only want to do solid lines or points of the items that are actually on the parabola or what you want to graph. So if I moved up 1, I'm at 3, -4. Well, likewise, if I move up 1 for my focus, I have to move down 1 for the directrix. And the directrix is a line that can never come into contact with my parabola. So it's going, and again, it's perpendicular to our imaginary axis of symmetry, so that's my line. And we always write a horizontal line as y equals whatever the value is, and that happens to be at -6, 1 lower than my vertex. So now I kind of have my parts. So now I know, again, the parabola goes in here somewhere, but how do I know how skinny or wide to make it? And that's where focal width comes into play. The focal width is always the absolute value of 4p, or the absolute value of the number in front. Well, the absolute value of 4, which again, hopefully remember means what's the distance away from 0 that 4 is? Well, 4 is 4 units away from 4. So I'm going to go, because it says focal width, it's because it's at the focus. At the focus, my parabola is 4 wide. Well, since a parabola is symmetric, I know I'm going to go 2 to the right and 2 to the left. That's a total distance of 4, and that tells me how wide my parabola is right there at the focus. So what I'm going to do is just kind of connect the points, graph my parabola, and that's it. We're not going to get any more detailed than that in this chapter. So let's look at example number 2. This is not in standard form. So the first thing I want to do is, you always want the parentheses that's squared all by itself. So the first thing I'm going to do is actually put it into standard form. So that means this should be on the other side. Well, this was a positive term, so if I move it to the other side, it's going to become a negative term. The only thing that changes to a negative is this 16. Everything else just stays the same, because that negative makes the whole term negative. So now that I did this, I know because the x is squared, it's either up or down, but this is negative, so I know this is going to face down. Okay, so now I want to find the vertex. It says x plus 1, so I know this is a -1. Y minus 5, so this is a positive 5. So I'm going to go -1 and then up 1, 2, 3, 4, 5. Again, that's my vertex. I'm going to use the number in front to figure out my p value. I know this part is equivalent to 4p. So if I, again, divide both sides by 4, which you will always divide by 4, I'm going to get p equals -4. Now what does this mean? That means you're going to go down 4 from this. 1, 2, 3, 4. Now that's where my focus is, which happens to be -1, 1, which again is 4 below this. Well, if I move down 4 to get to the focus, that means I have to move up 4 to get to the directrix. And again, it is going to be perpendicular to the axis of symmetry. And the axis of symmetry is the imaginary line that goes through our vertex and focus, so right here. So now I've graphed both of those. That is a horizontal line at y equals 9. And then my last thing is I need to figure out how wide this is going to be. Well, remember, the width is just the absolute value of this number in front of my parentheses. Well, the absolute value of -16 is +16. So again, remember, this is focal width. So I'm going to go to the focus, and again, this is why I use an X to help me know which one the focus is. It's going to be 16 wide here. Well, since it's symmetric to the axis of symmetry, I'm going to go 8 to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And then 8 to the left. Okay, make sure you just go the same distance both sides. And now that I have those 3 points, again, we're going to go connect through the dots I have, not any of the x's. So I'm going to graph my parabola as best I can to go through those points. And there you go. In example number 3, I can tell that this is not in standard form because my parentheses squared is not alone. I have this 1/8 there. So to get rid of 1/8, I'm going to multiply both sides by 8. So if I multiply the left side by 8, okay, 8 times 1/8 becomes 1. And if I multiply the right side by 8, I can just put an 8 in front of my parentheses. Again, we don't want to distribute anything because we want to keep it in our standard form. So now this is a little weird. The y is the part that's squared, which lets me know it's going to be either left or right. But because this is a positive 8, I know it's going to face right. So my parabola is going to look something like that. Now, this is where some students make a mistake, because remember, my vertex is x comma y. It's not go left to right. I have to look at the x. It says x plus 4, which means I'm going to get a negative 4. It says y plus 3, which means I'm going to get a negative 3. So I'm going to go left 4, down 3, and graph my vertex. Okay. To find the focus, again, I look at this. I know 4p equals 8, so hopefully you can do this. P equals 2. So which direction am I moving? I'm moving right 2. So go 1, 2. Because again, remember the focus has to be inside my parabola, and I know my parabola is going to go like this somehow. So if I go right 2, that puts me at negative 2, negative 3, which again is right 2 of my vertex. But then I have to move left 2. Well, again, because my directrix has to be perpendicular to this axis of symmetry that goes through my vertex and focus, I know this is now going to be a vertical line for my directrix. And again, it cannot come in contact with the parabola at all. And if I graphed it horizontally, it would hit it. Okay, so now that I have that, that's a vertical line, which is x equals, okay, this is going to be negative 6. And now I want to find my focal width. Remember, focal width is just the absolute value of this number in front of my parentheses. Absolute value of 8 is 8. So I'm going to go to my focus, again, focal width, and now it's going to be 8 wide, but now it's going to be up and down. So I'm going to go up 4 and down 4. And again, going through just the dots only, I'm going to be able to graph my parabola. And let's look at one last one. Here, I can already tell that it's in standard form. It's going to be left or right because the y is squared. This is negative, so it's going to go left. If I go for the vertex, it says x plus 1, so I'm going to write a negative 1. Y minus 2, so I'm going to write a positive 2. So negative 1, positive 2. My focus, I know 4p is equal to negative 12, so that means that p equals negative 3. And again, it's negative because I'm going left 3 from my vertex, which if I go left 3, I'm at negative 4, comma 2. Now, to get the directrix, I'm going to go right 3. And again, this is going to be vertical, so it's perpendicular to the axis of symmetry. And that's going to be a vertical line, so it's x equals positive 2. To find my focal width, I'm going to take the absolute value of the number in front of my parentheses. Absolute value of negative 12 is positive 12. So again, I'm going to go to the focus, which is my x here. I'm going to go 12 wide, which is up 6 and down 6. And then down 6. Okay. Again, the points are the parts that are actually in my parabola. So now I'm going to try to go through. Remember, you're not drawing this like a V. It should be curved, and they should have arrows on it because they do go on forever. I hope you feel a little bit better about graphing parabolas in the sense of conics, and you are able to find the vertex, focus, directrix, and focal width, and you feel comfortable graphing the parabola from standard form.